Hey, what's up? I'm Nishit Tarantula, and this is the part 2 of our series of trigonometry. In the part 1, we discussed about what is trigonometry, what is the meaning of this word. We broken down this word into 3 parts: trigonometry, and discussed about what they mean and what trigonometry is and how it deals with right triangles. Also, we discussed about trigonometric ratios. First of all, we discussed about what ratios are, what they actually mean. So let me give you a recapitulation for ratios. So ratios are basically mathematical objects, you can say, which are used for the comparison between two entities. For example, let's say I have a card, let's say, and this is the length, this is the breadth, and let's say the length is 2 times its breadth. So we can say that the ratio between the length and the breadth of the card is 2:1. Now, if I want to construct a whiteboard, let's say, which again have its its length twice its breadth. So let's say this one. So here again, the length is twice its breadth. So again, the length and breadth are in the ratio of 2:1. So we say that both the two are similar, as they have the corresponding angles equal and the ratio of the sides are equal. So same here in right triangles. So trigonometric ratios are basically the ratios of the sides of right triangle, which makes up our sine ratio, cosine, tangent, cosecant, secant, and cotangent. And also in the part 1 we derived this identity: tan theta equals sine theta over cos theta. We know that cotangent of angle theta is just the reciprocal of tangent of angle theta, and tangent of angle theta can be written as cosine of theta over sine theta. Therefore we can say that cotangent of angle theta is, this is sine theta over cos theta. So therefore we can say that cotangent of angle theta can be written as cosine of angle theta over sine of angle theta. This is our second identity. Now let's consider a right triangle. Let's say this one here, ABC, where B is 90 degrees, and let this angle be theta. Now if I ask you, what is, with respect to this angle theta, what will be the value of sine squared theta plus cos squared theta? Let's find it out. So we know that sine theta is opposite over hypotenuse, that is sine of this angle theta will be AB, and as this is squared, so AB square over hypotenuse AC square, plus cosine of angle theta squared, and we know that cos theta is adjacent over hypotenuse, so it will be BC square over AC square. Simplifying this, we'll get here AC square, AB square plus BC square. Now you'll notice that AB square plus BC square is nothing but AC square according to the Pythagoras theorem. So AC square will be AB square plus BC square. So we can substitute AC here, so we'll have AC square over AC square. Cancelling both terms will give us 1. Therefore we can say that sine squared theta plus cos squared theta is equals to 1. This is our third identity. Now we can use this identity to derive some more identities. Let's take an example here. We know that sine squared theta plus cos squared theta is equals 1. If we want sine theta, we can first of all, if we want sine squared theta, we can subtract cosine squared theta from this side and from this side as well. So we'll have sine squared theta will be equals to 1 minus cosine squared theta. Now if you want to solve for sine theta, it will be sine theta equals under root 1 minus cosine squared theta. And this is our fourth identity. Now we can do same with cosine. So if you want cosine of angle theta, so cosine squared theta will be 1 minus sine squared theta. We will take the square root of both the sides, that is from the square root of the LCM and the square root of the LHS and the RHS. So we'll have cosine theta is equals to under root 1 minus sine squared theta. And this is our fifth identity. Now let's take two triangles, triangle ABC and triangle NSC prime, and you're given that AB is parallel to NS and BC and SC prime are parallel to each other. Well, most importantly, you're actually given that triangle ABC is similar to triangle NSC prime. So if this is the condition, then you can fairly say that if we take this angle as, let's say, theta prime and this angle as theta, so we can say that theta is equals to theta prime, if you know the similarity criterion of triangles. So now if I consider both the two triangles in this way, you can see I've just changed that C prime with C because both the two angles are equal, so let this angle be theta. And now if I ask you, will the trigonometric ratios for the angle theta vary for both the two triangles? Will they? Because both the two triangles have different lengths. So this NC prime is larger than AC, and also other sides. So there's a difference between the sides, corresponding sides of the two triangles. So if I ask you, will the values of the trigonometric ratios differ for both the two triangles? What's your answer? Let's find it out. So I've considered both the two triangles in this way, where AB is parallel to NS. So according to the basic proportionality theorem, also known as the Thales theorem, if you use this theorem, we can say that CA over CN will be equals to CB over CS, and that will be equals to AB over NS according to the BPT theorem. Now let's take this part right over here. So let's write it here. So CA over CN equals CB over CS. Now if we take this CB right here and replace it with the CN, so we'll have CA over CB equals CN over CS. Now let's have a look at this term CA over CB. CA over CB, so we have the adjacent with respect to this angle theta and the hypotenuse. So let's do the reciprocal. So we'll have CB over CA equals CS over CN. So this is the CB over CA is the adjacent over the hypotenuse, that's the cosine of angle theta for the smaller triangle, and CS over CN, that's again the cosine of angle theta. So you'll notice that both are equal to the trigonometric ratio of cosine of angle theta, so both are equal to cos theta. Now you have noticed that for the smaller triangle, for this triangle, the trigonometric ratio is cosine of angle theta, and for the greater triangle, triangle NSC, the trigonometric ratio is again cosine of angle theta. That means it's proven that it doesn't matter what are the lengths of the triangle. What matter actually is the angle, the value of the angle, because mathematics is such a configuration that it gets you to the same result every time. Doesn't matter what length you choose, because you're always gonna get to that same result. So this is the beauty of mathematics, by the way. So what we can conclude is that for a particular angle, the trigonometric ratios will always be same, and that is regardless of the length of the sides. So cosine theta will be same for this smaller triangle and as well as for this greater triangle, until and unless the value of theta doesn't change. So for this triangle, the trigonometric ratio of cosine of theta is same as the trigonometric ratio of this angle theta. So now let's get more briefly done. So let's take this part here and write it down here. CB over CS is equals to AB over NS. Let's replace both the two terms, so we'll have CB over AB equals CS over NS. Let's do the reciprocal. We'll have AB over CB equals NS over CS. Now you'll notice that AB is the opposite side with respect to this angle, over CB is the adjacent side with respect to this. And also NS is the opposite with respect to this, and CS is the adjacent side with respect to angle theta. And we know that opposite over adjacent is tan theta. Therefore tan theta will be equal for both the two triangles. Now take these two terms. So we'll have CA over CN equals AB over NS. Let's replace both the two terms. We'll have CA over AB equals CN over NS. After the reciprocal, we'll have AB over CA equals NS over CN. Now, you can notice that AB over CA, that's the sine ratio, that's opposite over hypotenuse, and also NS over CN is opposite over hypotenuse, that's sine theta. So our statement is proven. And if you do the reciprocal, you'll have cosine theta, secant theta, and cotangent theta, and same for those trigonometric ratios. And therefore it is concluded that the values of the trigonometric ratios remains the same until the angle doesn't change. And also the trigonometric ratios of an angle doesn't depends upon the length. That's because this configuration of mathematics always gets you to the same result. So maybe the video is too long, so I will, in the next part, I will tell you the trigonometric ratios for different angle values. For example, 0 degree, 30 degree, 45 degree, 60 degree, and so on. So let's meet you in the next video. See ya. Bye. And if you have any queries, you can just ask me in the comment section. Bye bye.